Yeah, welcome back to Emoji Economics. My name is Onwali Godwin. In our previous class, what did we talk about? We talked about matrix inversion. So there we're able to learn how to derive the inverse of a matrix using the adjoint of the matrix as well as the determinant of the matrix. So in this video, as promised, we'll be talking about how to use matrix inversion to solve simultaneous equations. Now here in this video, we have an exercise that contains three linear simultaneous equations. Okay, so how do we solve this? Now first we express the equations in matrix form. We have 4x1 plus x2 minus 5x3 equals 8. Then minus 2x1 plus 3x2 plus x3 equals 12. And 3x1 minus x2 plus 4x3. Then 3x1 minus x2 plus 4x3 equals 5. Now note something because there are lecturers that are funny or teachers that are very funny. I could be one of them sometimes. So the thing is that the variables may not be arranged in the same order. Okay, so here you could have 4x1 plus x minus 5x3, and here this could start with minus 3x2, then you have plus 2x1 plus x3, and this could start with, let's say, plus 4x3 plus 3x1 minus x2. So you have to take note of these things. You don't just see a question and boom, you start to solve. No, it's not like that. So check if the variables are in order. If they are not in order, please arrange them in order. And there are times when, let's say 3x2, here this might just be minus 2x1 plus x3 equals 12. That is, you don't have x2 at all. Right? So what you have to do there is, you rewrite it in the form of minus 2x1 plus 0x2. Alright, 0x2 then plus x3 equals 12. Now I'm saying all of these things so that you won't think your teacher, your lecturers are wicked when they set questions like that for you. So we express this in matrix form. So we've said that our variables are arranged in order: x1, x2, x3, x1, x2, x3, x1, x2, x3. That's good. So expressing this in matrix form would have, the numbers, the coefficients. For the coefficient of x is 1, here is minus 5, so 4 1 minus 5. Then this is minus 2 3 1 minus 2 3 1, and this is 3 minus 1 and 4, 3 minus 1 and 4. So we call this matrix A, and it is actually the coefficient matrix because we pick all of the coefficients and form them into a matrix. Then we have a column vector because that's only one column, and the column vector contains is called the solution vector. That is the variables we are looking for, right? The variables we are trying to solve all of whatever we're solving for, called the solution vector. So and this contains the variables arranged in their chronological order. So this, when you multiply this by this, you get all of these equations back. Now let's just say, for instance, when we multiply this by this, so we have 4 multiplied by what? X1, right? This is x1, then plus 1 multiplied by x2, right? Then plus minus 5 multiplied by x3. Okay, so this 4 times x1 is 4x1, plus 1 times x2 is x2, minus 5 multiplied by x3 is minus 5x3, which will give us this back. Alright, so by the time we do that for the remaining, that's the same thing. You are going to get all of the equations again. Then we have this third column, okay, which is called the vector of constant terms. Now that contains all of these constants, because these are constant. You don't have any variable besides them, so these are constant. And then we have the vector. So it is more or less what you have here equals this. Writing it in matrix form, because what you have here is simply this times this. Then you have equal, then you have another column vector which contains. So you are going to be having column vectors basically. They are not going to be more than, if it were a 2 by 2 matrix, you'd have had x1, x2, 8 and 12. But it's still going to be a column vector, yeah, basically. So how do we solve this? So this is matrix A, right? And we call all of these, solution vector x. We look for, because it's expressed in terms of x variables. And then we said this is the vector of constant terms. So what we're basically doing is this multiplied by this to give us this, right? And that is A, matrix A, multiplied by the matrix x equals B. Now how do we get x? Because x is what we are solving for. So by the time we make x, so it's the subject of this equation, just divide through by A, and that will give you 1 over A multiplied by B. Now 1 over A is simply the inverse of A, right? So that is x now is the inverse of A multiplied by B. So that's it. Now the thing is, by the time we look at this matrix, this was actually the same matrix that we used when we were dealing with matrix inversion. So I'm not going to be resolving through the minors, the cofactors, the adjoints, and all of that. I'm not going to be doing that again. So I've just written out the inverse, what we got as the inverse. Now that video is the video that precedes this particular video. Alright, so you can just check the description, click on that link. There's a link in the description. It takes you to the channel's page. Go to playlist, click on matrices, and then find the video on matrix inversion. So it comes before this. We try to arrange them in a chronological manner. And the other thing you could do is just scroll to the end of this video, then a playlist will be suggested to you, the matrix playlist. You click on the matrices playlist, and it takes you to all of the matrices videos, and you check the video on matrix inversion. It's the video that precedes this. So that would give you an idea of, or that would teach you, not give you an idea, it's more than a 31-minute video. So that will give you an idea, that will teach you how to get matrix inversion. And we did a lot of things there, we did a lot of things. So it's a video that you should really check out. So from there we got the inverse of this matrix to be this. Alright, because this was basically what we didn't have all of this, sure. This was what we had. And finally the inverse will give us this. So the formula that we have to use now is the inverse multiplied by this vector of constant terms, right? So that's going to give us our x. So what we'll just do next is, so we say x would be, I'll write all of this again, 0.13, 0.01, 0.16, 0.11, 0.32, 0.06, minus 0.07, 0.07, and 0.14. Alright, 0.14. Okay, so x is this multiplied by the b, the vector of constant terms, and that is 8, 12, and 5. 8, 12, and 5. Okay, and so that is equal to, so we are trying to get x1, x2, x3. So that will just be, this row multiplied by this column will give you the x1. So what do I mean? So we have 0, let me put it in this way. So we have 0.13 multiplied by 8, right? If you don't know matrix multiplication, so we have our third video on matrices in the matrix playlist is on matrix multiplication, either the third or the fourth. If we did addition, introduction to matrices first, addition, then multiplication, then determinants, all of those things. Alright, so we've arranged them chronologically, and if you just go through them, see, we are going to thank you forever for understanding matrices, or for teaching matrices. So 0.13 times 8 plus 0.01 times 12, right? Plus 0.16 times 5. All of this will be equal to x1. And when we finish this, so this will give you 1.04 approximately, plus 0.12 plus 0.8, and that will give us 1.96. And 1.96 is approximately 2, so x1 is approximately 2. Or let me just say x1 is equal to 2. Let's just leave it that way. So it's equal to 2. So the next is we multiply this row by that column again. So you have 0.11 multiplied by 8 plus 0.32 multiplied by 12 plus 0.06 multiplied by 5. It gives us what x2. I believe I've not written nonsense. 0.01 times 8, 0.02 times 12, 0.06 times 5. Now that will give us 0.88, right? Plus 3 points. Please don't just be looking at this and be nodding your head. Make sure that you have your pen, your book, and you're writing these things down. You are verifying with your calculators. Okay, 0.03, and this will give us 5.02, which is approximately what 5, and that is divided by x2. Right, and the third now is for us to get x3. This multiplied by that, so minus 0.07 multiplied by 8 plus 0.07 multiplied by 12, then plus 0.14 multiplied by 5. That gives us x3, right? Minus 0.8 multiplied by 8, 0.07 multiplied by 12, 0.14 multiplied by 5. That gives us x3. So this is minus 0.56, then plus 0.84, then plus 0.7, and that's going to give us 0.98, and 0.98 is approximately 1, right? So x3 equals x3, right? Equals x3, so x3 is 1. Now if we want to arrange them in terms of coordinates, I just say x1, x2, x3. So it's going to is this. So x1 is 2, 5. I think so. Then 1. Right. So that's the answer. That's the answer. So that's how to do matrix inversion. So I'll be leaving an assignment now. okay, at the end of the class, so for you to do matrix inversion on your own. So let me just change this. Let me just if I should change this, so that means I don't want it to be lazy, so I want to do all of this, okay. Let me change the whole thing. Let me say this is 3x1 plus x2 minus 5 equals, let's say, 6. Now I'm just trying to bring this question from I'm not bringing from the table, so you might be getting a negative x, you might be getting decimal, so there's a possibility of that. So I'll just change this to, let me change this to minus as well, 3x minus x2 minus this, so that means x1 is really big. Okay, let me just change this to, let's say, 10 or minus 4. So that's minus 4. So let's say I just made those changes. Yeah, okay, should I try to touch this? Let me try to touch this guy. So x3. So I will just say 2x1 plus this plus, let me just change this to 2. Yeah, plus 2. Alright, so we are going to, this is the system of linear equations, simultaneous equations. So what you are going to do for me is to find the inverse. You solve this. Let me just solve. The question is just solved using the inverse method. So you are solving this system using the inverse method. Recall now that you are going to find the minus, the cofactors, transpose it to get the adjoint from adjoint, get the inverse, and from the inverse you then move to solving. So it's going to be a pretty long thing. All right, and I want your final answers in the comment section. Your final answers should be something like this. So x1 is this, x2 is this, s3 is this. So that's just what I want. All right, and if you decide to point this in an advanced calculator and it gives you the answer, and then you write the answer, you're just deceiving yourself basically, all right, and I won't want to do that. I really want to understand this thing. So that's it about the video. You have the assignment already. Please make sure you click on the subscribe button. If you are just seeing the video for the very first time, it shows you a notification bell. Click on that bell, and that takes you to, that notifies you of more of our classes immediately they are available. Like this video. Like this video. Why? Because you really gain from it, right? And we've put in a lot, to make sure that you get this for free. Please make sure that you like this video, share it with your friends, share people around you, share it with your colleagues in school, and so on and so forth. Thank you so much as we take on the economics to the world. See you in the next video when we talk about Cramer's rule.